Hello, thank you so much for having me here today. The title of my talk is How to Think About Large Language Models for Open Source Software Development, a hype-free approach that should still be relevant in a few months, that hopefully works for most OSS, open source software developers. So let me start off here with the beginning. I have a whole bunch of disclaimers up front. Okay, so first of all, opinions are my own, not those of my employer. The biases are my own too. I am a longtime open source software maintainer, and that's kind of how I see the world, but I realize everyone's experience in the world is different, so what works for me may not work for you. This is very much a how to think about talk and not a how to talk. There's plenty of how to use LLM talks out there, and plenty of them are very good. I didn't see a need to create another one. I just want to leave you with some questions and some good conversations for out there in the plaza, and maybe end with a bit of a call to action. But the other reason this isn't a how-to talk is that this topic is changing too fast for anyone to give a keynote about. I started preparing this keynote about 2 months ago. That's like 2 decades in terms of how fast LLMs and AI space is moving. It seems like there's a new model or a new layer on top of this stuff every day. And so I can't stay on top of it all. And if I say something in my talk like, we really need to do something about X, chances are someone already is, I'm just not aware of it yet. So don't take, we should do something about this as any sort of call that like no one's doing it. Now, thankfully, I've come up with a framework to talk about something that's moving this quickly. Back when I was in college in the 90s, studying computer science, the big battlefield then was around programming languages. Like, it wasn't clear that Python was going to take over the world, and it wasn't even clear which programming language would take over the world. And so a lot of schools, and I think still today, they focus on the things that tend not to change pretty slowly, like algorithms, data structures, distributed systems. And then when it comes to programming languages, rather than teaching any of the production languages, they actually use these teaching languages, like Turing and Eiffel. Hands up if anyone's ever heard of these. Okay, a few people, more my age group. So these were never really used in production, and they were never really intended to. They were just, helping students learn how to learn. And so I think this approach is something that we should be applying to LLMs today. Let's learn the big concepts and learn how to learn, and not sort of focus on this like news of the day, what's the latest model, what's the latest tool kind of thinking. So by treating LLMs as this unknown value, we can talk about general principles, right? Next disclaimer. I am not an expert in using LLMs for OSS software development. I want to break this one down a little bit. So what do I mean by expert? Well, anyone can become an expert given enough time and the right context and the right framework. That might seem really obvious, but there's actually a lot of psychological research that most people actually believe that their expertise is sort of fixed. And the really successful people are the ones who know that they can learn anything they put their mind to, given enough time and the right context. So that's sort of what I mean by expert. I'm not an expert now. I'm trying to become one. And I'm saying LLMs here because I want to be specific. I'm talking about these large language models that are all the rage right now, this sort of new wave of things, and not the broader field of data science or machine learning or artificial intelligence. And lastly, excuse me, I'm scoping this really far down to just talk about open source software development. So rather than all of the various things that LLMs are useful for, like drug discovery or drawing cartoons, this is just open source software development, and specifically open source, which I think is different from other kinds of software development or other kinds of technical engineering. I would argue that open source software development is actually more of a complex social structure than it is a technical skill or a technical activity. So when you put all of this together, it's clear actually that the number of people who are experts in these really sophisticated things called LLMs and who are also experts in these really sophisticated social structures called open source software development, the Venn diagram of people that are experts in both is probably vanishingly small. And I think that this AI expertise for software engineering thing right now is sort of the 20 years of Java experience they used to talk about in the 90s when Java first came out, right? There's sort of this expectation that we're all experts in it already when it just hasn't existed very long. Okay, so next disclaimer. The other problem with LLMs is that the discourse around them is full of anecdotalism, so people just sharing one little data point, and polarization, people trying to take a position that's, really at one of the extremes, right? So in software development for a long time, we've teased people who say, oh, this works for me, as if that's good enough. And of course, we know it isn't good enough when software just works for you on your machine. You actually have to build something that's general enough to work out in the world. The analogy here is something like, if I say, I had a cold and I took some echinacea, you can't claim that the echinacea cured my cold. You'd actually have to have a big study with a large population where you studied the effect of echinacea on that population to actually create any causal link between that as, curing the virus, right? And so it's really surprising to me that in LLMs, we're still at the point where many people are just saying, I tried this thing, and it was amazing. Or they say, I tried this thing, and it sucked, right? Like, that's not really useful for understanding how these things work in the real world. So one way I like to think about this is pretend each of these blue dots is an opinion about LLMs, and I've mapped them on a 2D space. So on the x-axis, we have impact. So like over here, they think LLMs are going to have this huge impact on the world, and over here you think they're kind of, not all that impactful. And then how positive that impact's going to be. Is it going to destroy the world, or is it going to create this brave, new, amazing world, right? And so you can take things you see on LinkedIn or on X or on Blue Sky or whatever and map them on this, right? So AI is just a fad, like probably not going to have a whole lot of impact. Over here is, I built my whole app in a weekend. This is kind of like the vibe coder opinion, right? Over here we have AI will replace all software engineering jobs, frowny face. And over here we have AI will replace all software engineering jobs, happy face, right? The emoji's doing a lot of work there, and I think tells you more about the person saying the thing than really what LLMs can do, right? So all of those things are kind of extreme polarizing opinions, but it's in this middle circle where I think we can have constructive discussions. This is the interesting part. This is how you can actually move the field forward, right? And if we want to make them better and we want them to work for us as open source software developers, this is where we need to be thinking. And I think one of the problems actually is that social media, of course, is designed to amplify those outlier opinions. And LLMs is sort of the first major technological advance we have had since Facebook, and that is not doing us any favors in terms of understanding how these things work and talking about them and trying to make them better and deal with their issues. Another reason that this anecdotalism is so sticky is that LLM evaluation is just really hard. It's just a really, really hard problem to figure out how good are these things really. So, like, again, throw back to the 90s when I was learning machine learning. It was pretty typical there. If you were training a model on a data set, you would take the first half of the data set to train your model, and then you'd use the second half to evaluate how well your model was doing. Like, I'm oversimplifying that vastly, of course, but it was very easy to understand how that worked. And unless you were like a bad actor, pretty hard to game this. It's pretty straightforward. LLMs are like just way, way, way more complicated. And like even the sort of state-of-the-art benchmark for software engineering tasks as well with LLMs, which is called SWE bench, has a lot of controversy around it because it's just very hard to do this in a way that's repeatable and understandable and also covers all the necessary use cases. I got another disclaimer. I have two more. This is the second to last one, I promise, okay? This is an important disclaimer. We all make mistakes, right? So when I think about evaluating LLMs, I don't think of my baseline, the goal, as trying to be the perfect programmer, because that doesn't actually really make any sense. The world is really messy. We're building software for the world, and so you're always going to have this like interaction that is very messy. So I think it's much more useful to like benchmark LLMs against how humans really do, and we do know that they all make mistakes, right? So with that, I want to tell you about the favorite bug of mine that I helped cause. When I say we all make mistakes, I'm including myself in that group. So back in 2007, I was working on matplotlib, and the big problem we had there was drawing circles was really slow. And how we drew circles at the time was we just drew them like a polygon. So it was a polygon with 100 sides. And anyone who's ever done any graphics rendering knows that the standard algorithm for filling a polygon is like n times m, where n is the number of sides and m is the number of scan lines. And so when you want to have a circle that looks nice and round, it's actually pretty slow. So I came across this paper that showed that you could actually approximate a circle using 4 Bezier splines, and therefore the filling algorithm would only have 4 splines to work with rather than 100. It gets a whole lot faster. And even though it's not a perfect circle, the math in the paper shows that the error is like 1 in 246,000 or so. And so the napkin math I did at the time was like the largest screen you could buy was 1,600 pixels wide, so you're not going to see the error there. And a piece of paper is like 7,000 pixels. So even if you had a circle filling the entire page, you're not going to see the error. But of course, then along came the Phoenix Mars lander. And they were using matplotlib, and they were using it to plot the trajectory of the spacecraft towards Mars. And so if you think about it, the size of Mars is maybe as big as this remote, and the trajectory is bigger than the size of this stage, right? And so they saw something that looked like this. And the bug report was really interesting, because they were like, yeah, the lander's already on its way. It's going there at about 12,000 kilometers an hour towards Mars. And in a few weeks, we are going to have the press over and some senators, and they're going to watch this up on the big screen. And we don't want it to look like it's going to miss. Now, thankfully, they weren't actually using this for guidance. This was just like going to be up on one of these big screens, like you see, right? So kind of a fun bug, and kind of had a very hard deadline. So interestingly, reverting the change, sorry, let me go back to this one. Reverting the change to just go back to the polygon circle drawing doesn't actually fix the bug either. So the fix, I'm not even going to get into the fix, but it was sort of, you truncate at the edges and you do the math just on the part you're going to see, and you can get it a lot better. But I think here's the important things about that story. Anticipating all the use cases that your code is going to be used for is really hard, right? I had no idea that JPL was going to use it for this use case. Testing before deploying is really important. So they tested this in their lab at least a few weeks before they were going to use it, which is better than nothing. And when they found the bug, they reported it upstream to matplotlib. And I, as a developer of matplotlib, was able to help them quite quickly. And then when the fix made it into matplotlib, anyone else using that library benefited from the fix. So it's not just a latent thing that everyone's going to have to come along and fix later. It gets fixed once. Okay. Sorry for the detour. Last disclaimer. Ethics really matter. I don't want to get up on stage and talk about LLMs without mentioning this. It goes from climate-threatening energy usage to amplification of bias to labor market disruption, intellectual property issues, and on and on and on. And I am going to touch on a few ethical quandaries later in the talk that I think are specific to open source software. but I can't effectively cover all of the ethical issues with LLMs in this talk. I think these issues are all really important, and anyone who's using LLMs should be aware of these pitfalls and supporting people who are working on solving these problems. But I also don't think that taking the position we should just ignore this until everything is fixed is terribly practical either. We can actually learn about these things and use these things in parallel with these problems being worked on and fixed, right? I also think it's totally fine if you have ethical issues with these things and you decide to avoid them for yourself. And I think it's really important that as an open source community, we are open to the people who are using LLMs, and we're open to the people who are choosing not to use LLMs. For my own part here, you may see my slides are really simple. I didn't do any Studio Ghibli art, and that's kind of an ethical choice I made. I also didn't use an LLM to write this talk. I had a couple humans help me review it, but that's about it. So you're seeing sort of me, right? Okay, on to the middle part. How are we doing on time? We're great. Okay, so this is the typical open source software development workflow for contributing a PR to an open source project. I think every serious open source project at this point has a workflow somewhat like this. They're all slightly different and different, you know, depending on how mature your project is, you might be more or less rigid about these things. But this is the high-level thing that kind of GitHub encourages and is pretty common, right? And you can actually use LLMs to help you with any of these tasks. But the framework I want to present today is that these tasks fall into different categories, and therefore you should be thinking about LLMs differently as you do each of these tasks. So the first category I have here is called learning tasks. So when you are generating the idea, the thing you're going to do, LLMs can be very helpful with like summarizing all of the bug reports in your bug tracker and then prioritizing ones that it sees a lot, things like that. Code base understanding is a really big one. LLMs, I think, do a great job of where you say, please read through this code base and tell me what the major components are and how they fit together and how, you know, suggest some ways in which I might tackle solving this problem. And then I think these are pretty low risk. Like if the LLM gets this wrong, all maybe you've done is wasted a little time. But so the next category here are these creating tasks, or this is like actual content that is going to end up in the open source project. So this is writing your tests, writing your code, documenting that code. These tasks get a lot of attention. I think this is sort of like everyone wants the LLM that will do these things for them. But strangely, I think like somehow in open source, they are less important than many of the other tasks. But I think the way to think about using an LLM to help you here is you still need to take full personal responsibility for everything that you're ultimately submitting. So even if you used an LLM to help you at various steps, whether it's auto-completion or maybe it wrote some lines of code, it's never going to be okay to submit that and say, the LLM did this for me. I don't really understand how it works, but it kind of seems to work, so maybe that's okay. Like that sort of, I don't think flies in the open source community. So it's fine to use those tools to move you forward, help you find a solution, but then you need to do the hard work of understanding that solution and being prepared to defend it as it goes into review. Oh, one important side note on this too, everyone thinks that documenting the code is for your users. What's really interesting actually is LLMs are taking on. LLMs do a much better job of using code that is well documented. So you need to also be thinking about your documentation as being useful for other LLMs in the future. Okay, the next category I have here are these collaborating tasks. This is where I would say the open source community, members of the open source community sort of come together. So it is really important to be real and be human here in these tasks. So like when you first report an issue, be yourself, like come at it from, I was trying to solve this problem for myself and this is what came of it. And not just, I don't know, the LLM said this thing was wrong and so I'm trying to fix it. Open source maintainers are trying to make connections with other people, and if they feel like they are talking to a robot, they are much less likely to help and much less likely to put in the time. And I don't really see a world in which this becomes fully LLMs talking to each other with these tasks specifically. I think this is where like community building happens. It is completely reasonable for all of these tasks to use machine translation if the project is an English language project and English is not your first language. Obviously, using a machine translation system to better communicate is totally fine. Technically, that is an LLM, but I think that's not intermediating your humanness in any sort of negative way. Okay, then the last category here are these risk mitigation strategies. So the first two here are kind of deterministic. The linting on your code and the testing of your code is not really using an LLM. It's a tool that's going to be deterministically like, this is okay, this is not okay. And these obviously have existed for a long time to mitigate the risk of any change that a human makes, right? And these are not going to go away in the world where LLMs are writing more of that code. In fact, I think they're now, important now more than ever. So those will sort of stay around. Code review is an interesting one here, right? It has been shown that the more reviewers you have on a PR, the better, the more likely you are to discover errors early and correct for them. And it is now, of course, possible, many of you may have seen that GitHub Copilot will review PRs for you, and it puts its own sort of reviews and suggestions into the mix. I really think they're at the point where those are just other data points that you need to put into your review mix, but they are not the final arbiter of quality and taste and safety and all these other things. So I do think it adds value, but we're not there yet as a replacement. My biggest worry with code review and where it may go in the future is code reviewers, like longtime open source maintainers, get pretty good at predicting the kinds of mistakes that humans make. And I think they're still learning to see the kinds of mistakes that LLMs make because they are slightly different. And so there is this new problem of kind of getting used to that maintainers are going to have to build. Okay, so in summary, we don't have to really change how we work too much to accommodate LLMs because we can accommodate some additional risk in some of these steps because we already have risk mitigation steps elsewhere. But what happens, now we're going to think of LLMs as this variable value and push it to either ends of the spectrum. What happens if LLMs get really good, okay? One of the worries is that there will be this flood of PRs coming in, and the bottleneck remains the maintainers here in the code review step, right? So now we have a lot more PRs coming in. The maintainers who are already super overwhelmed are now even more overwhelmed with more PRs, right? And maybe these PRs are lower quality because we don't really believe in the LLMs. So that's one outcome, and I'm going to talk later about some projects that are very concerned about that. That's the sort of like traffic jam outcome of LLMs, right? But a more optimistic view might be that the LLMs are helping to improve the quality of what's being submitted before it even gets to the maintainer. So you could imagine an LLM that's able to do a first rough review of every PR and say, hey, it seems like you don't have tests. Or hey, it seems like you imported this library, but you actually used this other one. Or these sort of very easy things. And then that may actually reduce the burden on maintainers who don't see that sort of work-in-progress stuff and don't have to do quite as much back and forth. I don't actually know where that's going to end up. But I think in conclusion about this, I think one thing is pretty clear, that for maintainers, reading code is going to even more overtake writing of code. The job of the maintainer is going to be much more about like connecting the issue that's coming into the real world, evaluating it, which it already is today, but I think LLMs are kind of accelerating that. My worry here is that pedagogically we know that people learn how to read by learning how to write. So like in school, if they want to teach you how to evaluate a really good argument in an essay, they don't just have you read 100 essays, they have you write an essay, right? Because that's the sort of constructivism model of learning, is that you have to do it in order to understand how to evaluate it. If we stop writing so much code, are we going to still be able to become good at writing code? I mean, I think that's an open question. For open source contributors, I think your reputation as a good contributor is going to become more important than output with LLMs, because LLMs are going to help you with that output, help you perhaps be more productive in that way, but it's ultimately your reputation and your ability to filter that output and turn that into a community connection that ultimately is going to matter. And also for contributors using LLMs, I think it's really important to not fall into this productivity trap. And what I mean by that is there's sort of this like assembly line Fordism view of how software development works, which is just, it's an assembly line, you do this thing over and over, and really you should be taking a stopwatch, time yourself without the LLM, then do it again and see, if it takes 10% less time with the LLM. That is really not the way to be thinking about knowledge work. That's not how it works, and that's not how open source software development works. I would instead suggest that you think about these things as you're using LLMs. Are you connecting better to the projects that you either use or you contribute to? Do you have an improved understanding of what is actually going on in those projects? Do you have more confidence contributing to those projects where it might have felt daunting before? And lastly, are you able to learn from like building a throwaway prototype, maybe have the LLM build something really quickly, and then build the real maintainable thing? So these are like things measured in weeks or months, not things measured in seconds. And I think that's the really important framing when you think about, is this LLM worth it for me? Okay, so this leads me into a new topic. Based on this framework of how open source software development works in the world, over the past 6 months or so, we've seen a lot of open source projects adopt these open source generative AI submission policies, both because they're interested in the promise and also concerned about some of the potential downsides. So I'm going to walk through a sampling of some open source policies, open source generative AI policies, just to give you a flavor of the kind of things that maintainers are concerned about. So this is the CPython developer's guide. And they say these acceptable uses of generative AI include assisting writing comments, especially in a non-native language, so that's that machine translation thing. It's acceptable to use it to gain understanding of code, contributor knowledge. These are learning tasks, right? And the concern here is that there will be a bunch of low-quality PRs that are going to overwhelm the maintainers. And that's why they say the maintainers are free to just close your PRs that are not useful or productive. They don't even have to explain why, including any of those that are fully generated by AI. So this is sort of allowing some very clearly beneficial uses of it, but also concerned about some of the, I guess, like throughput concerns, right? The Linux Foundation has guidance on this stuff. They want you to treat all your contributions as if they're coming from peers. So this is, again, taking personal responsibility for anything you submit. But then the Linux Foundation adds a bunch of concerns sort of related to IP and copyright. They're concerned that maybe the outputs of an LLM will be under the copyright of whoever produced that LLM. I think it's not quite clear where we're landing on that. You know, will the outputs output something like plagiarism, right? And then there's plagiarized content in your open source project, and then can you still defend your own copyright on that project? These are the things they're concerned about. Fedora project has a policy. Again, this embrace your human side thing comes up again. I think that's really interesting. They're concerned about just low quality content. This do not use LLM tools to expand your talking points is an interesting one. If you can say something in one sentence, they want you to continue to say it in one sentence and not let the LLM ramble on for you. So I thought that was an interesting one. And then they also sort of evaluate submissions, much like a paper review, and they don't want you using LLMs there because they're concerned about bias. This last one is interesting. It's a bit of an outlier. So Servo is a new web browser engine written in Rust, and they are, I think, a more political project because of who they are. And they're basically saying, no, just no LLM content at all. And then they do go, I've excerpted it here, abridged it here, but they sort of have concerns in these 4 categories: the burden on maintainers, correctness and security, copyright issues, and a lot of the ethical issues. So these policies right now are kind of all over the map. I think that's interesting. I think eventually, like we've done with licenses and codes of conduct, there's going to be probably 3 or 4 different options that everyone kind of settles on eventually. But for now, as a contributor, you really should be aware of the policy of the project you plan to contribute to. So now I want to go back to that bug. We were talking about a Phoenix Mars lander heading toward Mars and it looking like it's going to miss, right? Let's pretend that I'm the author of that software called Phoenix here. And this is how open source dependency graphs usually work. It depends on matplotlib. Maybe they met the author of matplotlib at a conference and they thought he was nice and seemed trustworthy, so they depend on matplotlib. Matplotlib in turn depends on a bunch of other things, NumPy, and then NumPy depends on Python all the way down to Linux, right? So this is, if you've ever done a pip install, this is what's happening, right? And let's say, for example, this nameless project down here suddenly tanks in quality because they start using LLMs and their vibe coding and all of these things we're worried about. There's already a bunch of systems in place to sort of notice when projects become problematic in the open source world. It's not perfect, but there are companies you can pay to help you with this. There's also kind of a non-paid social contract around open source projects that eventually it would get out that this project was deteriorating. Don't depend on it, or at least roll back to the old version before it started to go off the rails. One thing related to this that I am a little concerned about, we saw that XZ backdoor last year where a state actor was impersonating an open source contributor in order to gain the rights to then insert a backdoor in that software, right? That was presumably done at the speed of human beings actually doing those interactions. But LLMs are a really good human impersonation tool, right? So if we can impersonate open source contributors at scale, does that mean that these sorts of things will actually become more likely? I don't know, but that's definitely a counter-argument to the usual open source corrects for itself. But now let's suppose, back in 2007, that the author of the Phoenix Lander software had access to an LLM. And so, rather than seeing this bug and reporting it to matplotlib, they just said, hey, LLM, ChatGPT, Claude, whatever it is, they said, hey, there seems to be a bug in the circle drawing in matplotlib, could you please fix it for me, right? I think it's much more likely that the LLM would just work around that bug. It would fix that bug in the local project, right? Rather than noticing that it's a bug in matplotlib and then going to submit it upstream. Now, I don't want to claim that every time you find a bug, you have to submit it upstream to the project. That we're all really busy, we don't have time for that. But how open source works, of course, is that a certain percentage of people who find bugs do report them upstream, and that's what keeps the quality and the effectiveness of all this software moving forward. And so if you have LLMs that are never going to understand that it should submit upstream, eventually that whole system upon which open source is based will grind to a halt. And what's particularly troubling about this to me is that when you understand how the LLMs work, being trained on that open source project, what's actually happening is the knowledge in the commons is being brought into this local user who says, fix my bug for me. And then the value that extracts is going to the provider of the LLM. So it's actually sort of starving the commons of what it had rather than recontributing back to it, right? So that's a really big concern of mine in terms of how LLMs are packaged and built today. So that gets me into my concluding part of the talk, is that we really do need to start thinking about tools that are purpose-built for open source. So a lot of the reasons these policies exist, I would argue, is because the tools we have today are not understanding about how open source works. And if we had those tools, they might be more open to allowing such things. So there's a few things that are holding back this future, though, right? There's some very obvious ones, like models are extremely expensive to build. By some estimates, the next version of ChatGPT is going to cost $2.5 billion to train, right? So that's not something that an open source community is very easily going to be able to do. They're built on IP that may or may not be tainted. You know, the people building these models right now are not terribly concerned about licensing in the way that the open source community is. And then that leads to the IP cleanliness, let's say, of these outputs as not being trusted by the open source community. And so it makes it really hard to bootstrap an LLM system that would be purpose-built for open source and work the way open source does. There's this long-running debate about, can you even call any of the LLMs we have today open, even though they use that word all over the place, right? So it's very hard to tackle that problem, but I think it's okay to say the LLMs for now, they're a black box. They are being provided by industry who have the money, who are putting this in. We are going to make this better. We are going to work on making them less expensive and less IP tainted and all those things. But in the meantime, we can keep treating this as a black box and build all this other infrastructure around it, the sort of packaging of the LLMs for software development, and inject an understanding of how open source works into these things. So, plagiarism detection is kind of different and kind of more important in open source, maybe in some contexts, right? How you're actually going to prompt it. You're going to prompt it, if you find a bug, submit a bug report upstream, right? These are things that are not built into our tools today, but maybe should be. My second conclusion is that the existing risk mitigation things we have in the way we do open source still apply, but they're probably going to need to evolve for different kinds of risks. The coding mistakes that LLMs make are going to be different from human beings. And the human impersonation problem may be a new risk that we now need to think about in terms of security of open source. And lastly, my conclusion, that collaboration and reputation in open source are going to matter more than ever. These sorts of coming together at conferences where we see and interact as humans, I think is going to be very important in a world where the work product is more automated. It becomes much more about the connections and the understanding of the world that can't be automated. And so with that, I think that's a great time to sort of conclude the day, or almost conclude the day. here at PyCon and start having conversations about these things and what we want to see this world look like and how we want to use LLMs in this context for us as open source developers. So, muchas gracias.